Okay, in this problem they tell us that the population is approximately normally distributed, and they tell us that the mean of the population is 18.7. The standard deviation for the population is 4.4, and we're going to take a sample of size 50, and they want us to find the probability that the mean of that sample is greater than 19.4. So the first thing I always do for these problems is I draw a picture. So a normal distribution looks like a bell shape. And let's see, we're talking about a sample. And because we have a population that's normally distributed and a sample size that's greater than or equal to 30, we can assume that the mean for the samples is going to be equal to the mean of the population, which in this case is 18.7. And for the standard deviation for the sample, you have to take the population standard deviation and divide it by the square root of n. So when you do that, let's see, that's 4.4 over the square root of 50. So that's equal to 0.62225. Okay. So when I draw my picture, then right down smack down the middle, the mean for the samples is 18.7. And the standard deviation for the samples is what we just figured out. It's 0.62225. They want us to find the probability that the mean of the sample is going to be greater than 19.4. So that's somewhere to the right of 18.7, and they want greater than, so they want this area. So remember that area corresponds to probability. Now at this point, we're going to do it just like we did before. We're going to find a z, but it's going to be x bar minus mu x bar over sigma x bar. So x bar is the value that we're interested in. It's the 19.4. The mu x bar we figured out is 18.7. And the sigma x bar is the 0.62225. So when you do that out on your calculator, I got 1.12. Okay, so remember what you do now. At this point, you have to take out that table that I gave you, and you go to the positive z side, and you look up 1.1 row. So you go down to the 1.1 row, and you go across to the 0.02 column on that row. So I think I get, hopefully you can see it, I get 0.8686. I want to make sure that's what I got from the table. I got 0.8686. So but remember how the table works. That's giving you the area to the left. We don't want the area to the left. We want greater than. We want the area to the right. So remember the whole area is 1, so it's 1 minus 0.8686. So 1 minus 0.8686 is 0.1314. Okay, so first thing you got to do is realize that the sample mean is equal to the population mean. The sample standard deviation is the population standard deviation divided by the square root of n. Use those values to plug in to get your z. Get a z-score. Look it up in the table. Remember that if we're saying greater than, you have to do 1 minus whatever you get out of the table. So that's what we did. We got 0.1314. So think of it this way. There's like a 13.14% chance that if you took a sample of size 50, you're going to get a mean for that sample that's greater than 19.4. So that's it. I hope that helps with these problems.